Now that we have a Git repository, let's talk about the basic Git workflow, what we do on a daily basis when using Git. So here's our project directory, and here's our Git repository, which is actually a hidden subdirectory in our project directory. Now, every day, as part of working on various tasks, we modify one or more files. When our project reaches a state we want to record, we commit those changes into our repository. Creating a commit is like taking a snapshot of our project. Now in Git, we have a special area or a special intermediate step that doesn't exist in most other version control systems. It's called the staging area or the index. It's essentially what we're proposing for the next commit or the next snapshot. So when we're done making changes, we add the modified files to the staging area or index, review our changes, and if everything is good, then we'll make a commit. The proposed snapshot will get permanently stored in our repository. So the staging area allows us to review our work before recording a snapshot. If some of the changes shouldn't be recorded as part of the next snapshot, we can unstage them and commit them as part of another snapshot. That's the basic Git workflow. Now let me walk you through a real example. This example is crucial, so pay close attention all the way to the end, even if you think you know the basics. Our project directory is currently empty, so we add a couple of files here. Now we are ready to record this state. So we use the add command to add these files to the staging area. Now these files are in the staging area. This is the state we're proposing for the next commit. We review these files, everything is good, so we use the commit command to permanently store this snapshot in the repository. As part of this, we supply a meaningful message to indicate what this snapshot represents. This is essential for having a useful history. So as we fix bugs, implement new features, and refactor our code, we make commits, and each commit clearly explains the state of the project at that point in time. So now we have one commit in our repository. Now, a common misconception about Git is that once we commit the changes, the staging area becomes empty. This is not correct, and I think this is why a lot of people find Git confusing. So what we currently have in the staging area is the same snapshot that we stored in the repository. So this staging area is actually very similar to a staging environment we use when releasing software to production. It's either a reflection of what we currently have in production or the next version that's going to go in production. So let's continue with our example. Let's say as part of fixing a bug, we make some changes to file 1. Note that what we currently have in the staging area is the old version of file 1 because we haven't staged the changes yet. So once again, we use the add command to stage the changes. Now what we have in the staging area is the same content we have in our working directory. So let's make a commit to record this state. Now we have 2 commits in our repository. Also look at the commit message. It's describing the bug that we just fixed. Now let's say we realize that we no longer need file 2. It contains unused code. So we delete it from our working directory. But this file is still in the staging area. So once again, we should use the add command to stage this change. In this case, the deletion. This is the interesting part. Even though we're saying add file 2, Git knows that file 2 is actually deleted. So it will delete this file from the staging area or the next snapshot. Again, we make a commit to permanently record this state. Now we have 3 commits in our repository. Each commit contains a unique identifier that gets generated by Git. It's like a revision number. Each commit also contains information about what was changed, by who, when, as well as a complete snapshot of our project at the time it was created. So unlike many other version control systems, Git doesn't store the deltas or what was changed. It stores the full content. With this, it can quickly restore the project to an earlier snapshot without having to compute the changes. Now you might ask, but hey Mosh, wouldn't storing the full content in every snapshot waste a lot of space? No, because Git is very efficient in data storage. It compresses file contents and doesn't store duplicate content. Now, as someone using Git, you don't really need to know how Git stores data. That's implementation detail and may even change in the future. What you need to know is that each commit contains a complete snapshot of our project, and this allows us to quickly get back to a previous state. So that's the basic idea. Over the next few lessons, you're going to see this workflow in action.